Rosenmund's reaction. This is also called Rosenmund's reduction reaction. Now, reduction means either removal of oxygen or it can be addition of hydrogen. So, here we are discussing addition of hydrogen. So, this is a reaction by which you can prepare aldehydes, that is by the reduction of acid chlorides. Acid means carboxylic acid chlorides. Say RCOOH is carboxylic acid and its chloride R, say we'll write it like this, RC double bond O Cl. This OH getting replaced by Cl. So this is acid chloride. So this on addition of hydrogen. Addition of hydrogen takes place in the presence of a catalyst, which is palladium, in the presence of barium sulfate. You get RC double bond O, hydrogen is added here and HCl is removed. So this is Rosenmund's reduction. So here hydrogen is adsorbed on the surface of palladium. And if you are not using barium sulfate, this reaction product will not be aldehyde, but you will be getting an alcohol. It will undergo further reduction and you will be getting an alcohol. Here you are getting an aldehyde because you are using barium sulfate as a retard. That is, it is retarding the reaction. See, hydrogen will be getting adsorbed on the surface of palladium. But if lots of hydrogen react with or gets added to this acid chloride, it will go on. After aldehyde stage, you will be getting alcohol as the product. But if some positions of hydrogen are occupied by barium sulfate, that is, some positions on palladium are occupied by barium sulfate, that many hydrogens will not get added to the acid chloride and the reaction will stop at the aldehyde stage. So that is why we are using barium sulfate. So we can say that hydrogen in the presence of palladium, palladium is the catalyst and barium sulfate will act as a catalyst poison or something which retards the reaction. So you have to remember this. Barium sulfate or quinoline. Quinoline is a sulfur containing organic compound that can also be used as a catalyst poison in this reaction. So always remember to write this barium sulfate if it is Rosenmund's reduction, because otherwise the product will not be this. The product will be an alcohol, not an aldehyde. So what if, say, benzoyl chloride, C double bond O Cl. Again, if it undergoes Rosenmund's reduction, you will be getting benzaldehyde. So this will be the product here. Now, will you be able to get formaldehyde, HCHO, by this reaction? It is said that formyl chloride, with which you should be starting to get this product, formyl chloride is unstable. And so you will not be getting formaldehyde by this Rosenmund's reduction. So remember, the catalyst is palladium. It is addition of hydrogen or hydrogenation in the presence of palladium. You have learned about platinum being used in the case of hydrogenation, but here it is palladium in the case of Rosenmund's reaction or reduction. And barium sulfate or quinoline can be used as a catalyst poison. So Rosenmund's reduction is reduction of acid chloride using hydrogen in the presence of palladium and barium sulfate to give aldehyde.